Yeah, thank you so much, Maria. Nice to be again here at Platform Engineering Webinars. So let me introduce myself. I'm Diana Todia. I'm a senior SRE at EQS Group. And today I'm going to be talking about generative AI and observability in the serverless world. So just a little bit more about myself. Like Maria said, I live in Valencia, Spain. I've been a serverability engineer for over 4 years now. I mainly focus on observability issues, but I'm also passionate about AI, open source. I support women in tech. And more about myself, I love foreign languages, so I speak 5 of them. I love traveling, like everyone does, I believe, and doing sports. So you can hit me up on LinkedIn to stay in touch and ask me any questions. And also you could check my GitHub repo for the previous conference talks or all the slides from my previous talks. Right, so let's get into it. Just before we start, I wanted to say that the opinions expressed in these presentations are my own. So they do not represent my employer. So mainly it's just like, let's say, if you want to take it like this, our opinions based on my experience and what I've learned so far. Right, so let's jump into the agenda. What we'll be seeing today, we'll be discussing some of the concepts relevant for generative AI. Then we're gonna touch some points on observability, how it integrates with generative AI. Then we're gonna look more in depth on the use cases of AI assistants. And obviously, we're gonna wrap it up with the lessons learned from all this discussion, right? Okay, so let's start. So as many of you probably already are embedded in this very reality of machine learning, I'm pretty sure that everyone that works in IT and not only in IT, but has learned about machine learning, ChatGPT, generative AI. So I'm pretty sure you have all the basic knowledge. What happened is that ML as machine learning is right now pretty much integrated or is trying to integrate a lot with the DevOps culture. So we've been hearing a lot the concept of MLOps. That's because like all the, let's say the practices in data science or machine learning are trying to embed as much as possible with the DevOps culture, which is a good thing in the sense that it can automate a lot of the DevOps functions and a lot of the workflows, right? What other trends can we see besides the MLOps? So if we take a look a bit more closely from the MLOps family, which is like, let's say the more general machine learning operations that, you can integrate it with a lot of things. Right now, the new trends are developing like LLM ops, right? So large language model operations, meaning that we are seeing a lot of LLMs focused on very specific use cases, on very specific applications. Then you can practically use it, I know, for marketing in companies or for something really specific like research and for students in education. So lots of, let's say, companies are focused more and more into developing their own LLM ops. And an interesting trend that for me was something really nice to see, and it's taken quite, let's say, a big turn at the moment, is something called LLM observability, which means that there are those LLMs focused on tracing the LLM apps productivity, latency, errors, and so forth. So basically, they are creating, let's say, LLM observability solely for the purpose of tracking, how those LLM apps function in reality, which is a good thing, right? So you don't want to have an LLM app that does whatever without getting all your information or your logs, all your traces that you can consult later and analyze. So that's something you probably new to see, and it's quite interesting to observe. And from this big family of ML ops, machine learning ops, we've been hearing a lot of AI ops. So what does it mean? It's just AI operations that are applied into the IT operations that we probably seen a lot on any website right now, like chatbots, AI assistants, and that's covering, let's say, a large part of the market at the moment. And something really interesting that I researched during these days was that there is an interesting trend to drop AI ops and focus more on agent SREs. What does it mean? So basically, there's a very big market there that focuses on SRE workflows. So as myself, I'm an SRE. There are a lot more, let's say, workflows, SRE type of workflows that if automated with ML, with machine learning, LLMs, and so forth, will create a lot of revenue. So there are people actually thinking about dropping the AI ops term and focusing more on these SREs workflows, how they can automate it, and how they can integrate it with machine learning. So let's say, watch out for that. It can be something really interesting in the future. Right. So right now we'll jump into the concepts part. Here we'll discuss some theoretical concepts that you might be familiar with or not. I'm gonna just put them there to remind them. So we cannot talk about LLMs, or we cannot talk about AI assistants or a generative AI workflow without understanding the basic term of transformer. I'm pretty sure you've heard about it. In machine learning, a transformer is a neural network that learns context and meaning by tracking relationships in sequential data, like the words in the sentence. So I put here the transformer architecture. That's a very basic architecture that has appeared like around 7 years ago, probably even before that, in already a classical article called "Attention is All You Need." So why we want to pay attention to this type of architecture? Because it's at the foundation of how AI assistants work in general. So we want to pay attention a bit more closely to what it entails. So the transformers, they focus on two main layers, encoder and the decoder layer, which at their own turn, they focus on the attention mechanisms. Some of them is called self-attention mechanism, and the other is called multi-headed attention. So what do they do, these attention mechanisms? So back in 2010, more or less, they were developed in the context of image recognition for human vision. And then they moved to focus on the objective of translation of long sentences, right? So for instance, English to French, English to German, that's in the context, obviously, of neural networks. So in this architecture that you see, the encoder will use the self-attention mechanism to compute the importance of each input token relative to other tokens in the sequence, and it will allow the model to focus on the relevant parts of the input sequence. So the attention mechanisms will allow a neural network to selectively weigh the importance of different input features, so the model can focus on the most relevant parts of the input for a given task. Right, so why is this important? This is important because it will provide us with a contextual understanding of each word or image token, and it will allow for nuanced interpretations. So yeah, that's very cool in theory. How does this relate to GenAI? So GenAI is not so different. It's actually super similar to the transformer architecture and how they work in general. You need to pay attention to these small parts. Basically, that once you work with the input data, let's say documents, images, audio, we use these real-world objects and concepts as vector embeddings. So forget about images, documents, audio. Basically, we will just use the term vector embeddings. And the semantic similarity of these objects will be quantified by how close they are to each other as points in vector spaces, right? So let's say, for example, when a GenAI architecture will think about, I'm using these terms, but obviously doesn't think about like that. We'll take, for example, concepts like from the animal world, right? Some animals, cat, dog, bird, and they will actually put them in the vector space close to each other because they have a lot of similarities. So the vector embedding representation will be suitable for common machine learning tasks like clustering, recommendation, and classification. Right, so basically what happens is that when we are querying it, those vector representation, they will search in the vector space for the nearest neighbor, and they will grab from that space the results. Okay, so how does the generative AI link to the idea of a vector database, which probably, of course, you've heard about it, and is super, super important when we are doing that query, right, with an AI assistant. Well, the vector database will be storing, right, will be storing those vector embeddings that we talked about, and they will also index those vectors. So when we're actually querying it, while we are actually looking for content, we are actually going to the vector database that will search for the specific vector embedding that will be indexed prior to that, and then post-processing will give back the result. So that's very interesting. It's very similar to how a normal traditional database works. It's just translated into the vector space. Why vector databases are, let's say, a lot more efficient than traditional databases is that they, when the query is happening, the search procedure is actually looking at that space, that vector space called latent space, and it's actually figuring out how close, based on the weights on the ranking, are those embeddings, right? And they will also understand, based on the vector space, the relation between each other. So it's quite an interesting procedure to find out. I will get into a lot more details later. Just for now, you can understand the fact that vector databases are super, super important when we deal with generative AI and with AI assistants. Right, so because we are talking today about serverless, we also have the versions of serverless vector databases that actually are more efficient, even, let's say so, than the normal vector databases. So how? They solve three main problems that a vector database has. So we'll solve the separation of storage from compute. How? Will be basically because we'll be using highly sophisticated geometric partitioning algorithms. And this will also be more cost efficient due to this partitioning. It will solve the freshness issue. So basically we'll add the freshness layer or temporary cache, as it's called. So meaning that when you're trying to access, when you are querying the database, the vector database, the index will already do the indexing part at the beginning in that freshness layer, and the information, the data will be already, let's say, immediately ready for querying it. So it's like already saves you time, basically, when you're accessing the information. And the third, it solves the multi-tenancy issue here. So this is a bit more complicated to explain, but the idea is that it will identify the users with similar usage and will collocate them while keeping full separations between them, right? And this is done based on the user metrics, automation allocation of what they call infrastructure based on usage. So there you go. You have quite an explanation that with the serverless vector databases, we are, let's say, a bit more closer to cost efficiency and to actual speed on how we are getting the information, right? So let's say in practice, some of the use cases. Right now, I'm going to give you some examples. Very, let's say, common vector databases, popular vector databases, also serverless, are Pinecone and Weaviate. On the open source stance is LensDB. And you can find obviously different other AIs or different other serverless platforms that work very well, like AWS SageMaker, serverless inference that will work deploying machine learning models on serverless. We'll have Cloudflare, Workers AI, that they're responsible for text generation, image classification. Hugging Face on Google Cloud Functions. They will use serverless natural language processing, sentiment analysis, etc. Anthropic Cloud API on serverless, the same for context generation analysis and question answering. And the list is quite big here with we are used to like the normal providers like Azure OpenAI with Azure Functions, OpenAI with AWS Lambda, the same, they do pretty much the same thing. Versal AI SDK, if you refer to SDKs, right? And the chat box like AWS Lex or Azure Bot Service. So these are just a few, let's say, popular examples on the market. Right. So going further in the concept area, we need to use, once we, let's say, have an LLM that we want to use, we have our vector database. What else do we need? Well, we need to also think about a retrieval technique for our use case. Normally, so let's say, I'm pretty sure you heard about them. The most popular ones are retrieval, augmented generation, and fine-tuning. And we will see a bit the differences between them and how they can help us. So the retrieval augmented generation is based on the transformer architecture that you've seen previously on the decoder and decoder layer, input and output, and is pretty much similar to the explanation I provided before. So the RAG will work with information from private and proprietary data sources, right? So think about if you're like a company or you deal with very private data, most likely you will be inclined to use this type of technique. So you'll have RAG that will start with the input query, and then the retrieval model will grab the information from databases, right? And the retrieved information will be converted into vectors in the high dimensional space, which will be then stored into the vector database. The retrieval model will rank the retrieved information based on the relevance to the input query, and the documents will, with the highest scores or the weights, will be selected for further processing. So this is like more or less how it works under the hood. And if you think about the, let's say, comparison with the fine tuning, basically you have like to focus on these two main differences. So RAG will use an external database on the fly to help generate responses, whereas fine-tuning will adapt an existing model to perform better on a specific task by further training it with that specific data, right? And you can also combine it. So let's say many, depending on the use case, you want to have both, right? You want to also pre-train a language model on raw data. You want to also fine-tune that model with a data set specific to your application. And you want to implement a retrieval component that fetches relevant data from an external source in real time. And then the fine-tuned model will use both the learned knowledge and the newly retrieved information to generate responses. So it's a nice combination. Just to mention, these retrieval techniques are not the only ones. So in machine learning, there are lots of them, and more or less others are being right now tested. And depending very much on the use case, you can be inclined to use other retrieval techniques, right? Right. So we talked about, let's say, the basic concepts, how generative AI architecture and the transformer architecture will blend in using AI systems. So this is why I wanted to give you this, let's say, more or less theoretical information, because it's, if you work with AI systems or not, you'll understand right now more, the relevance. So you'll have the transformer architecture that's like the basic, and you'll have the natural language processing. So basically the using images, text, audio, etc. That will be used for AI assistance. And let's say you want to track that application, or you want to find information, observability information that will help you in your day-to-day life, right? About observability, I'm talking about here data like logs, traces, metrics, synthetic monitoring, service level objectives, application performance monitoring. So we want to have all that data and we want to use it, we want to ingest it in the AI assistance. So let's see how it flows. I also mentioned here that we cannot escape observability without mentioning the OpenTelemetry. OpenTelemetry, if you know it or not, is a very, very popular open source project that right now is gaining more and more, let's say, the term of standard in observability. And obviously, the people from OpenTelemetry have already managed to, let's say, integrate all the terms for generative AI, and we'll discuss about this. So OpenTelemetry is very interesting because it has some very particular use cases, in special in regards to distributed tracing, contextual input data, spans, correlated logs. So due to the fact that it's open source and not vendor locked, will help, also integrated with generative AI. So if you have the chance or you already work with OpenTelemetry, it's good news that you can use that further along with generative AI. And some of the use cases or something that you can take in relation to generative AI is that it can help you capture traces. So that's basically the contextual input data that you can grab into spans. It could grab metrics, so something related to latency, costs, error rates, then correlated logs, like a full LLM, for example, response or a full prompt text. And you can analyze with the span links the patterns of input and output. Also, an interesting thing here with OpenTelemetry is that you can check the feedback in production and you can put it back in development. Why? Because the information, let's say you're going to the whole workflow with AI assistants, it's good to not only test it in development or staging environments, but also use it in production. That's where, let's say, the real magic happens. And the information you grab from there, you can actually put it back in development because you will detect some very specific patterns and we'll use that to further train your model and your pipeline. So keep it in mind to use that. Also here, I wanted to point the fact that it's a very interesting talk that will be in the resources page at the end. Philip Carter from OpenTelemetry actually gave a talk on how OTel helps GenAI. That's available if you Google it. It's on YouTube, like from a month ago or so. He gave it to Open Celebrity Community Day. So check it out. It's really awesome. See, it talks all about this information even more. Right, so going back to what we discussed before. So we want to ingest, we want to integrate our AI assistants with our observability data. So our observability data, also included, obviously, will be inputs into the knowledge base, right? So we want to create a knowledge base for our company or for test environment, right? So you want to put that into the user database. You can put observability information on GitHub repos, documents, articles, knowledge base articles, whatever you want, right? So right now, it's like you're starting to cook. So this is where the fun thing will happen. So like we've seen before, we are using that knowledge base information and we are asking the AI assistant, right? So imagine that's on the left side, I'm seeing left, probably you're seeing right. So on the part where it says vector search engine is the fun part where the AI assistant actually is starting to think. So I'm querying it from my side with a prompt, right? So I'm saying something like, give me some logs related to this date, related to this application. So I will use a prompt. Then also the information will go to the vector database. We'll start the vector search procedure. So we'll start actually looking into that latent space I was talking about and trying to retrieve the information from the latent space based on the weights, right? And we'll get the information with the help of the specialized LLM I'm using. It will give me the response. So we'll do also like the re-indexing, the post-processing part, and will give me the response. So this is how more or less AI systems work under the hood. There are a few steps there that we don't see, but anyway, we are probably accustomed to seeing all these components working together. So AI system will work like I said, with transformers and generative AI via the self-attention mechanism and parallel processing. And with the transformers will be held by the pre-trained transformer model, the fine-tuned domain-specific data sets. So think about, we talked about this in the fine-tuning part, and we'll get that information from the user query, right? So my query with my prompt. The generative AI, what does it do? It looks and is trying to create, provide you with that coherent and contextually appropriate answer. And actually looks in the history of other conversation, and is trying to understand and is trying to provide the right context for your response. So it's doing quite a lot of, let's say, interesting, I'm not going to say creative because it's not creative, but a lot of, let's say, interesting mechanism there, interesting processing, so you can get your response. So actually, let's say you want to use this in real life. You want to, probably you already played with it at your company or, I don't know, via GitHub repos, right? One thing you need to ask yourself, is my infrastructure ready? Am I gonna right now go at work and I'm gonna say to my boss, hey, I want to use GenAI or AI, doesn't matter, let's do it. Well, it's probably not that easy in the sense that you need to have your infrastructure quite stable, and you need to think about all these steps I was mentioning before. So let's take a real use case. And this is more or less based on my personal experience that I had with AI systems, GenAI, picking the LLM, looking at the prompts, picking the vector database, querying with my prompts, and actually putting in my data. And I found some interesting scenarios here. So first of all, let's say you have your vector database, your vector engine, you have your LLM that you picked before, but right now you're at that moment when you're picking the core information or core data for your knowledge base, right? So it can be observability, it can be marketing, it can be business data, it doesn't matter. So you need to prepare that data. You're thinking, should I put a lot of information like quantity? Should I put a large corpus of data, or should I use less data? And also, are you going to use like any data you'll see, just a giant, huge GitHub repo, or maybe you're going to fine tune it before, maybe you're going to clean it, you're going to denoise it a bit. So the answer is yes, please do prepare your data beforehand. You need to denoise it, you need to clean it as much as possible. You need to, let's say, fine tune it, but that's not like the appropriate term right now that you're more or less, let's say, more advanced with the term. And you want to use, let's say, a large quantity of data. Probably you'll see the result that you'll have less accurate results, you'll have less quality results. And why is that? Probably you didn't pick the correct LLM. So for instance, you're looking at some, I don't know, very technical data that you want to really find some very fine-grained information, like really taking a very, very close look at logs, and you're using the wrong LLM. There are very specialized LLMs on the market, so you need to pay attention to what they do, right? So each LLM has its science, each LLM does a very specific thing. So please choose accordingly your LLM. Then probably it was your prompt. So you started with, I know, a very ambiguous prompt or a very complex prompt, like a huge sentence that doesn't end. And you need to also spend some time reiterate over that prompt. Yeah, so it's not a problem. We all do it. So it's actually that funny part when you actually learn how to prompt engineer, right? And then you need to probably take a step back and think about the vector database. Did I choose it correctly? I don't know. Is it good for my use case? There are lots of features that out there on the market, so you can use, you can test with different vector databases. Right, and you can see right now, based on this, how it evolves. If you get more accurate results, if you get faster results, how do you feel about it? And then let's say you are inclined to use less data, right? So I don't know, in my test environment, I really don't need to use huge data, a lot of quantity. So I will do just like a couple of articles. And you'll probably see from the beginning that you have better quality results. It works faster, it's more accurate. And then you're gonna try to do this in production, and then everything will fail. Well, it would fail because production, right, is very, very different. Normally you use a lot of data that is not cleaned, a lot of noise. Also the prompts maybe are used in an incorrect manner, or just users basically using their own prompts. So those very, very good results would drop when you switch to production. So that's not a problem. These are all lessons learned. Everyone has their own, let's say, experience with this workflow. What we need to know is how next we can prepare. So how we can, let's say, work towards a better experience with the GenAI, with the vector database, with the vector engine, all these terms I mentioned right now. You need to assess your data, right? So you need to assess the data that you're putting into that vector database, that you're working with that vector database, your large corpus, right, of data, incoming and outgoing. Incoming, the ones that you want to add, your repos, your knowledge base, whatever, and the outgoing one. So you follow the pipeline, you follow the workflow, and you get some results. Please do like OTel community says, and actually it's not only OTel community, but the entire ML community says, just reuse that result back into the pipeline, back into the workflow. And like this, the entire, let's say, LLM, the entire workflow will start understanding more and more the patterns you are using, right? Because once you reach production, things will get messy. Choose the right retrieval technique, whether it's a fine-tuning, RAG, another one, mixture. Right now, we are getting more and more complex with that. Choose the right LLM or the small language model. There are very, very good use cases for small language models. So please pay attention to that. Please research it beforehand. The literature there is out there is great. Then, like I said before, the vector database, whether it's serverless, normal, choose it correctly. And then please pay attention to the infrastructure. You cannot go with an unstable infrastructure, put on top an AI assistant, and expect you get miracle results. It won't happen. So you need to also review your infrastructure. Also, you need to upskill and train yourself as an engineer and your colleagues. So take your time to do that. Look closer to the prompts you're using. So like literally nobody I've seen knows how to prompt right from the beginning. You need to think about being less ambiguous, being more concrete to that specific use case you're doing, more concrete or more, let's say, up to the point to the data you are using. And not only that, but you also probably, if you are working with very specific data, I don't know, business, observability, doesn't matter, you'll see like after a while, you'll start scripting your own prompts, which means that you get very, very complex prompts in the end that will look pretty much like a script. So I've seen that and people got very, very good results after that. And once, let's say, all the tests going great, you're gonna probably ask yourself, am I production ready? Is this production ready? Don't be afraid to go back to the chain, back to the beginning of the workflow with information, with the results you get from production, and feed it back to the test environment. Because you're gonna feed it very useful information, it will learn about the patterns, and you will learn also how to use it better, right? And last but not least, get some human feedback. The people that are using it, do they like it? How do they use it? How about the user interface itself? So I've seen also many cases where users were just like, okay, but we should have this button, or we should catch this right from the user interface. We don't need to wait for the whole workflow. So a lot of, like, let's say, smaller or bigger issues can be dealt or can be fed right in the user interface. So yeah, don't be afraid to communicate. Don't be afraid to go back to the users. Don't be afraid to collaborate with entire teams, whether it's engineering, whether it's machine learning teams, development, management, everybody, So everybody's a happy camper. So please get the feedback, as much feedback as you wish. So this pretty much wraps it up. I know it's a lot of information. Machine learning, generative AI in general is not an easy topic. And I prepare some resources here for you. You can take a look, the ones that I've used so far in this presentation. Please take a look at my GitHub repo. So all the slides are already there uploaded, and you can find my previous presentation with all the slides. You can hit me up on LinkedIn, stay in touch, ask me something related to this talk or observability in general, or Valencia. And yeah, not the least, we are hiring a TQS group in engineering. So if you're interested or know somebody the same, hit me up on LinkedIn. Okay, thank you so much. And I'm going to be all ears to your questions. Thank you.
Amazing. Thank you so much, Diana. Let's jump right into questions. I see the chat has been active throughout your session. So very excited about the questions you have. So the first question is, how do you make the AI assistant familiar with the company's OLM's data, indexing, embedding, telemetry data, logs, traces, metrics seems very expensive.
Yeah, true. Yeah, it is. I mean, that's why the point there about having your infrastructure ready is a very, very important point. Also, LLMs themselves and vector databases are quite expensive technologies, so we don't use that lightly. What happens is that because of the panoply, we are inclined to use in general with observability. So we are using, I don't know, multiple of 5, let's say, in terms of observability tools. My suggestion is to have less observability tools and focus on non-vendor specific tools like OpenTelemetry. Unfortunately, I at the moment, I don't think I have another open source standard for observability, but if you do encounter it, please use it. Why? Because let's say you want to switch from one vendor to another, then you don't have to rethink all the observability workflow, and we'll get always the same information, all basically the corpus, the big part of observability. You're getting the traces, the logs, the metrics, and you can feed it into the AI assistant. Very good point to the, let's say, the vector database and also the vector embeddings. The vector embeddings is basically the information that you are feeding, you are translating into the let's say the high dimensional space. Here you need to basically work with your company. So what is relevant for your use case? I mean, I'm pretty sure that if you ask a company like, oh, can we use like all the information available we have here for within an AI system, I'm pretty sure they will say no. So some of the information will be proprietary. There are still lots of companies that they don't want to deal with AI in general because of proprietary information, and also because they don't have the right skills to understand the entire machine learning workflow. So it's important here to understand the workflow, what does it do, and to use the right retrieval technique. And yes, please do, even if you have like a huge amounts of information, do clean it. You must clean whatever data you're trying to use. And you need to do that because like it was pointed very well, it will cost you a lot of money. You'll have a lot of repetition in your data, a lot of noise, a lot of information that you don't need there. So imagine that you have, let's say, the more you have, the more likely your LLM will hallucinate or will go wrong, will be less accurate. I'm not trying to scare you, but this is the reality in the sense that you need to be very, very careful about the information, the relevant information you want to use, right? So get rid of all the noise in your data and use the relevant data. And you'll see with experience, this will get a lot, let's say, more and more familiar. And also, like I said, probably you wouldn't be inclined to use large language models, but small language models that are very, very good for, let's say, something like testing, the development, and not only. So yeah, okay, going to another question.
Cool. Yeah, another question. Which SRE workflows do you think are the most interesting to automate with LLMs, AI assistants?
Cool. Yeah, nice question. So I've been getting this question quite a lot from not only SREs, but in general, people, engineers working in tech support will be incident related information. So will be that huge amount of, let's say, knowledge base articles, incident, even GitHub repos, rule books, right? Alerts, observability data. So all that information that is relevant when you are being paged at 3 a.m. in the morning, and you want to like, okay, I want to interact with my AI assistant. I obviously will not understand anything within the next 15 minutes because I just woke up. So I'll just write my, prompt in the AI assistant, and the AI assistant, if it's trained well, will link me also some of the alerts, what did it detect, the error, probably the root cause, and also the GitHub repo, the rule book, right? So the information, the workflow for the incident. So those are really, really handy. So by the time you wake up and you make your coffee, you'll be like, oh, okay, I know where to look. This reminds me of this. I know where to look. It can be APM. It can be, I know, some information regarding to some infrastructure issue. So yeah, this is the main objective.
Cool. Another question that there is, can you copy the reference links into the chat? I think we'll send over the slides and you will have those links. So yeah, you'll receive them in your inbox tomorrow. Then there is another question. Sorry for being blunt here. What is the need to have this in SRE model than adding a Shining project GenAI? What additional benefit current SRE going to get with this? This is still a reactive approach.
It's still a reactive approach. Yeah, okay, this is why I said, yeah, okay, yeah, no, absolutely, I agree. So I didn't say like all SREs want to use GenAI or AI in general. There are a lot of, let's say, colleagues out there, it doesn't matter, a lot of engineers that are quite reluctant. And the idea is that you won't see the benefits until you are using it. And just like any technology. And this particular technology is very, very, let's say, dependent on how you train it. So it's not something plug and play. It's not like, I don't know, I'm just gonna put it into action, wait for it, and then I'm gonna search for it. No, you need, so it's very demanding in the terms of you need to upskill yourself, you need to train yourself, you need to learn about the workflows, you need to integrate a lot of parts like you've seen. But the benefits can also be quite good in the sense that once the workflow is stable, based on a stable infrastructure, and you understand the gaps in your infrastructure, it can be really, really useful. It can automate a lot. It can speed quite a lot. So in the sense you'll gain time and be very, very efficient. I wish I could give more, so let's say advocacy for GenAI, but I won't do it because it's something that it's very, very linked to experience. And it's very linked to the fact that in order to understand the benefits of a technology, you first need to use it, right? So nobody will tell you or can tell you, just use it, just trust me. No, just, do it at your own pace. Probably you'll see it at other people in other companies being used. And then once it's like a by default trend, then you'll probably have to give in and learn about it. So yeah.
Yeah, totally. What are some of the data processing strategies to use LLMs in a cost-effective manner on top of observability data?
Right. So can you repeat that again, the beginning? Sorry.
Yeah. So what are some of the data processing strategies to use LLMs in a cost-effective manner on top of observability data?
Right. Right. This is very much has to do with, so one will be the vector database that you'll be using, because this goes, so selecting a vector database, selecting a vector engine is basically a decision, an infrastructure decision. We will make you save costs. It will need to be applied to your own use case in your specific company with the data you are using. So you need to figure out that by yourself. Next, obviously, you want to implement observability data. Why? Because it's good to understand how your applications are working, where do they fail, even LLMs, like we've seen the LLM observability part, to understand where those LLM apps are going to fail. So this is why we want to integrate it. It's probably going to cost you money in the long term. And also you have to think about, which tools you're going to use. And then think about the model you are choosing, right? So it can be large language model or small language model. They're very, very specialized. So you need to select that carefully. And also, just like researching and seeing things, you need to pay attention to the retrieval technique. This is super important. I just gave you a couple of very popular techniques, RAG or fine-tuning or the mesh. You can use the mix, but there are so many others. So machine learning is a very, very wide, very mathematical domain, and you need to research it properly. So please go ahead, use the links I provide you, use information online, and there are many others, and many of them haven't been tested properly with the right information because, yeah, it's a very, let's say, it's an evolving domain, but there are many more retrieval techniques available out there. These are just on top of my head. I'm pretty sure that we can ask more this in a machine learning type of or data scientists that they can provide more information, more technical information around that.
Yeah, makes sense. Can you please share some business use cases, case studies for observability with GenAI?
Yeah, sure. So one of the main, this presentation was focused on the SREs and developers in general, so the DevOps world, engineering, but you can extend it to so much more. So you can use observability, depending, like I said, even if you're not, let's say, into the engineering part, if you are like marketing or business, whatever type of domain you are, you can use LLM observability just to understand how your LLM applications are being used, right? So that's a very, very common use case. Normally, you want to use observability because if you are implementing machine learning type of workflows, data science workflows, I'm pretty sure that you want to have a trace of what is happening there. So you don't want to have, let's say, everything focused on one team that is using it. You want to have it more visible to other teams as well. And also this will be cost effective because more people will understand that observability data and will be widespread right in the company. These are the use cases. Many companies are using it, even like government-related, organizations are using it. OpenTelemetry, I know from OpenTelemetry projects that they have quite a lot of use cases in all sectors due to the fact that it does distributed tracing. Large companies are using it. So yeah, sky's the limit. The idea is that open observability, OpenTelemetry, anyway, they will provide you logs, metrics, traces, then you can use to debug or everything that happened there. So don't restrict it to just the engineering domain. Think it a bit like from another perspective that you can actually use it in this context as well.
And one last question that I see here, could you give an overview how other retrieval techniques differ from RAG?
RAG.
Uh-huh.
Right. Okay. Yeah. So the fine-tuning one is the one I provided to be say the most popular, and it's used in regards to retrieval augmented generation. Others they can be very various. So like I said, please use the information in Machine Learning Q&AI. That book is really, really awesome. It enumerates like lots of retrieval techniques, and it goes into very, let's say, technical details. It's like, I'm not a machine learning engineer, so probably I'll make a mess just trying to explain the whole list of retrieval techniques available. But there are many there that are very interesting, and some of them that haven't been, like I said, fully tested, in the sense that the retrieval techniques are yet scientific. Basically, they're right now being discovered, and they're trying to be tested. So if you are, like, for instance, going on the archive website that they publish the scientific machine learning techniques and anyway related information. Every day they come up with new information, new articles saying, oh, okay, this technique and this information. So sky's the limit. Don't put a pin into a retrieval technique. Just go out there and search it and get to the roots of the question. I'm pretty sure I wouldn't make much sense right now after 45 minutes of explaining the basic concepts. So I'll just take a pause. But yeah, please do get information from the resources and all the machine learning scientific articles.
Perfect. And I think that's a wrap, because I didn't see any other questions. So thank you so much, Diana, for leading this insightful sessions. Like, we don't have too many talks about GenAI, and I think that's just a start, as it's coming, and very cool to see that you're already using it in your SREs workflow. So very cool. We need more of these sessions. And thank you so much to everyone who joined us today and asked questions. All the flowers to you in the chat, which is also great to see. I will send over slides and the recording to everyone who registered, so you can expect that in your inbox tomorrow. And yeah, if you're interested more in the platform engineering content, you can also like sign up to our either like LinkedIn page or on the meetup where we publish those events. We usually host them every week, so you can choose whichever what topics interest you, or even become a speaker yourself, since we usually you just need to submit the content and the topic you would like to speak about. But with that, I think, yeah, I hope everyone has a great end of the day, great dinner here in Spain. I guess it's time for dinner so late. But yeah, once again, thank you so much, Diana, and hope everyone has amazing end of the day and end of the summer. Shit, it ends this week.